Hey everybody, what's up? This is Nils. Welcome to my YouTube channel. So glad to join you here this week. This week's topic is about 3 technical concepts that are pretty important to know as a product manager. And in addition, a little discussion of how technical you really have to be an effective product manager. And the answer is you have to be somewhat technical. You don't have to be a coder. You don't have to know how to write code, but you have to know some ideas that are going to help you communicate better with your developers, understand better what your application does in real life, and things like that. Hey, if you like this video, please click that like button. Feel free to subscribe if you want to hear about all the new videos that are coming out on this channel. They come out about once a week, sometimes a little more often, sometimes a little less. And if you have any thoughts or responses to the topics in this video, please leave me a comment. I'd love to hear whether you think this was very useful or whether you think it was dumb. Love to have that conversation. Either way, I respond to all the comments. So feel free to comment. Let's see, subscribe, like, comment, all those things. Well, the topic for today is what are some of the key technical concepts you need to know, even if you're not a technical product manager, right? There's always this question, if you're not a programmer, can you be a product manager? Because, the question keeps coming up because so often the job descriptions say, you need to have a CS degree or an engineering degree. But the fact is that if you talk to most product managers, they're going to say that's not really necessary. So where is what's the breakdown here? Where is how does this come into it? Well, the fact is that having some technical knowledge is really valuable as a PM. In fact, I would say if you're a software product manager, you need some technical knowledge, but you need a specific type of technical knowledge, and it doesn't mean you have to be a coder necessarily. In fact, it may be that if you're a coder, that's a handicap in some cases. But as a product manager, I never read or write code, or unless I do it for fun, really. Sometimes I occasionally do it for fun. I do have a tiny bit of a background of having learned to code. I'm not a professional programmer by any means. I can't do any of those things that real coders do, but I do know a little bit about code and I can read it slightly. So that makes me, a little more technical than some product managers, a lot less technical than others. But, the bottom line is you don't really need to be that technical. So what are the things that make a good product manager? Well, there are some characteristics you need to have, and they're all equally as important, if not more important, than technical knowledge, although technical knowledge is one of them. You need to have empathy for your customers, for your stakeholders, for the people you're working with, all those folks, in order to be able to deliver a good result. You need to have, you need to be able to both see the big picture and pay attention to detail in a way that isn't, a lot of people don't have to do both of those things. So it's sort of an executive type of function to some degree to have the focus that's the big picture focus as well as the small picture focus. You need to be able to have strong opinions and put your opinions forth and convince people and persuade people about your opinions, but you also need to be willing to change your mind if evidence presents itself that says you're wrong. And this, of course, something that happens all the time. As we're learning things about our customers, we may have an assumption, we may have an opinion for whatever reason, and we may find out as we go along that it's wrong, or we may find out that the approach we're taking with our solution is wrong. And so we also need a lot of mental flexibility. We need to be able to switch context really quickly. We're not good, probably, well, at least I'm not, at sitting and doing one thing for 8 hours at a time, unless it's a video game. But if it's not a video game, then I can't do it. But, whereas some of our colleagues in the development organization, that's what they love. They love to sit down and wrestle with a problem. Maybe to them it's kind of like a video game for hours at a time. But that's not what our job is like. Our job is we're always switching context. We have people coming to us with questions. We have to quickly figure out answers. We have to do prioritization. We have to write something. We have to do 15 things a day, and it's a different 15 things every day that we have to do. So we have to be mentally very flexible to be able to achieve that. And of course, we also need to have really good communication skills. We have to be numerate. It's really important for us to understand how numbers work and, kind of what is the difference between a million and a billion, and have a gut feeling about that is meaningful, in order to make good decisions about products, and not just a million and a billion, but small numbers like the ones you might get When you do a new marketing campaign, you know, what's our percentage improvement in a marketing campaign? And how do we spin that percentage improvement as being a factor of 10 improvement? That's the type of thing that we often have to do. But of course, we also need to have technical credibility, and that's what this video is about, and the other videos that will be upcoming in this series, right? If you need to work with tech teams, but you're not a developer, the fundamental thing you need to remember is that you're mostly focused on problem space. You're focused on finding market problems, helping the development team understand the problems that the market is facing, and much less about solution space, which is their job. Their job is to solve those problems that you come to them with. Of course, you have to validate that the problems, or rather that the solutions that they come up with, solve the problems well. So we do interact with solution space, but our big job really, as we're working with on our products are solutions to problems. Our big job is to make sure that we solve the problems well, which is sort of a problem space kind of thing to be thinking about. And of course, when we're going out and helping sales get ready to sell the solution, it's how do we make sure we find the people that have the right problems? How do we make sure we articulate that we understand their problems? Now, of course, we also have to articulate that we have those solutions as well. But we do a lot in problem space, and we work with our team in solution space. Now, this slide is actually from my last video, which was about how to drill down deeply when you're doing market discovery. And I said, well, we have to stay in problem space. You have to stay out of solution space. We're working on trying to get people to tell us things that they didn't know they knew about their problems. And of course, we're also trying to overcome the fact that we think we know more than we really know. So the bottom two points on this slide are really from a different presentation. I just thought it was funny as I was trying to put this presentation together. I thought, well, that's interesting. This really lines up with a lot of what I need to talk about in this talk. So stay in problem space and focus on problem space. That's really where we need to be in terms of, even when we're working with technology, we need to stay a lot in problem space. So let's, though, talk about a bunch of the technical concepts that will help you out and help you succeed, whether or not you're technical, when you're when you're being a product manager. And so some of the ideas are things like the idea of a repository. And I'm going to talk a little bit more about the first three items on this list, and then later on we'll talk about others. But the idea of the framework of this development stack that we work with, and how do we need to interact with that as product managers, or what do we need to know about that? What about metadata? What about order of magnitude and the database and API? These are all technical things that you need to have some understanding of. You don't need to be able to code, as I said, but you do. It's very helpful if you understand what these concepts are about, because you can then use them usefully in conversations to learn about the issues that are going on with your, as people are working on solutions. So, these concepts, and this is not the full list of concepts. There's probably a few, maybe a dozen more. This is like 13 or so. There may be another dozen really important technical concepts to know if you're a product manager. I would say these are some of the most important, and these are some of the ones that I had to learn when I was first starting to learn to be a product manager. So let's dive in, though, and talk about what these all mean. So the first one that I want to talk about is the repository. And just because, for me, this was, in my recollection, I came into the job of product management with some knowledge about coding. Again, I was not a programmer, but I knew a little bit about coding. I'd learned how to code. I'd done some technical writing, and I knew a lot of technical stuff. But this term repository came up, and I didn't understand it. And I actually had to ask somebody about it. The architects were talking about the repository and this new repository that was coming out and this and that. And I didn't know what that meant. And so one thing I did, even though, and I had already the respect of these folks I was working with, which was good, but I asked them, what is the repository? And basically they said, well, it's really just a word for where the data is. It's not an actual thing. It's not necessarily a technology. It's a concept. It's the place where the data is. And oftentimes, not just the data, but where the relationships between the data are. So The way to think about the repository is in contrast to things like flat files. Now, flat files are just files that you might work with like an Excel spreadsheet. And the problem with an Excel spreadsheet is that if everybody starts with the same Excel spreadsheet and then they all work on it, all of those Excel spreadsheets are now different. And so everybody has a different picture of the world. Now, a lot of enterprise software products are really taking that idea of, here's a thing that I do in a spreadsheet, let me put it in a database or a repository, and let me put some user interface on top of that. And then we suddenly have a single source of truth, meaning that everybody's working on the same data and it doesn't start to diverge over time across multiple different spreadsheets on multiple different people's desks. And so that is the basic concept of a central repository, is that that's where all the data is. It's where the single source of truth is. It's where everybody can go and access it. It's typically multi-user. And so it's versus a flat file. It might be versus multiple disconnected databases or loosely connected databases. And with the idea that, it's a single source of truth. Now, a repository is usually a database of some kind, as I said, but it can also be maybe multiple connected databases if they're relatively tightly coupled. Or again, it can be mostly conceptual. You can talk about a repository, or you can talk about how a set of data is a repository, even if it doesn't necessarily fit these other parts of the definition. So for example, as product managers, we go out and talk to customers, and we each individually go talk to customers. We take our notes and we put our notes into the wiki, maybe, or we put them into a database of documents. And if you talk to a particular customer and I go talk to the same customer, even though those two conversations should be conceptually related in some way, they're probably not in terms of our documentation, but we still are going to think of that as the repository of our customer conversations. And so it's really conceptual, even if it doesn't fully define all the things that we might like it to do. Now, one thing that helps that concept be a repository is if when you go talk to that customer again, you put the information in there. If you want to gain some insights from those conversations, you gain them by virtue of going into the repository and editing and putting your comments onto the items that are in the repository, so then everybody can see those later. So that's how that comes out as a repository. Now, let's talk about some examples of repositories. So just as an example, the question that often comes up is, do we have the data to do something? So example, can we wish our users a happy birthday when they log in on their birthdays? And so the question is that data in our repository? Do we have that data? This is the type of thing that you can answer if you have that data. Or, sometimes the developers will come to you and say, well, you've asked me for this feature. I'm not sure we can do it. And then a really good question to ask is, do we have that data in our repository that we need? And if we don't, then that's a good reason to not be able to do that feature. If we do have that data, then maybe we have to have a deeper conversation about why we can or can't do that feature. And so that's just an example. The question is, do I have the data? That's the bottom line of what you're looking for when you're talking about a repository. Now let's talk about another really important concept, which is the stack. Now you've often probably heard that one of your developers might be a full stack developer. You might see that, a job listing for a full stack developer. Well, what does full stack mean? And what is the stack in this context? And the stack typically is the set of components, the technical components that make up your solution. So that's going to include things like the hardware and computers that your solution runs on. Now, this may be hardware that you host. It may be hardware that's hosted in a hosting environment. It may be the cloud. It may be virtual machines that are running in the Amazon or Google Web Cloud. And so that's just part of the stack. And typically the more important question about those computers is not the computers themselves, but what the operating system those computers is running is. So it might be Linux, it might be Windows, it might be iOS. If you're a mobile developer, your stack is going to be, the hardware is going to be a phone, and the OS is going to be iOS or going to be Android most likely. And then the next level of the stack is the programming languages that are used to write the code. And there's actually different types of languages that are used on different parts of the stack. And then there's the the sort of application servers and web servers that run on that hardware to deliver your services. And we're not going to get into web servers and application servers in this conversation, but basically those are pieces of software that help deliver your application to the users. There's also the database server, which holds the repository for your data. And then there's the UI code and the framework that might be living on top of those things that helps deliver the user experience. And so that's something often you'll hear about JavaScript, or there's the Angular framework, which is a framework for working with JavaScript. Those are just some potential languages or UI frameworks that you might hear about. Now, some examples of these, until recently, the LAMP stack was a very common stack. It's changed a little bit. A lot of the components are still there, but LAMP stood for Linux as the operating system, Apache as the web server and application server, MySQL as the database, and PHP as the programming language, so that the acronym LAMP. And it was a very easy way to get a new application up and running quickly, and you could often get these hosted. And so this became very well known. These are all open source components, and so that it was basically very free, or nearly free, to run an application on the LAMP stack. Now, in contrast, another really important stack out there is the Windows stack. And the Windows stack runs on a Windows server, and it uses SQL Server as the database. Now, Windows Server includes a bunch of the middleware, what's called the middleware, like the web server and the app server and things like that. And then there's languages that are associated tightly with the Windows environment, and those languages are typically under the rubric of .NET. There's actually quite a few different languages. And there's technology related to UI in that stack as well. So those are two common stacks. Now, the LAMP stack is typically it isn't typically Linux, Apache, MySQL, PHP. It's often Linux, Apache, Oracle, and Java. That's a very common stack also. It doesn't have a good acronym like LAMP, but that's one that a lot of enterprise software applications are built on because Oracle is a more enterprise level database and Java is a more enterprise level coding language than PHP. So that's a typical thing for enterprise software. And there's lots of other stacks. But the point is, what do you need to actually know about this? Well, you don't actually need to know all these technical details, really. What you need to know is that there are some implications of your choice of a stack, or of the organization's choice of a stack, from a business perspective, right? So, for example, whether it's on-premise or it's hosted or it's in the cloud, those are going to have different impacts on how much it costs to run the stack, on how much it costs to keep the stack running. If you host your own servers, then you have to have people who are focused on keeping those servers running 24/7. Whereas if you put your whole application up in the cloud on Amazon Web Services, somebody else is keeping those servers running. You do need to monitor them, but many of the basics are actually handled for you. Of course, you pay a little bit for that, but you don't have to have full-time people who are swapping out disks and things. That's what Adobe does. So there are cost implications and business implications, and there's also some customers that don't want their application, their data, to be running in the cloud in that way. Mostly, I think most of those customers have learned that it's okay, really, to have the data running in the cloud. But for a long time, there was a lot of pushback from corporate customers in particular about having their data up in the cloud. And as I say, I think a lot of that's been addressed, but there are still questions like that. And if you have highly sensitive data, and you need to really control access in a really controlled, maybe top secret way, right? You might not use a cloud solution. You might do on-premise hosting. Certainly, if you're doing anything for the military that's classified, that's going to be that case, right? It's not going to be connected to the internet. Again, the choice of Windows versus an open source stack like the LAMP stack or one of its descendants, that's going to be a big question because the Windows stack is a lot more expensive. Of course, when you start talking about the LAMP stack but using Oracle as a database, that becomes expensive too. So there's all these different questions that related to the business. The other really important thing to know about the stack is that changing stacks, you don't want to do it very often because it's very, very expensive to do this. And it often causes development to stop in terms of new features being added for a long time as you switch everything over, because in the old stack, there was a bunch of functionality, and you need to either replicate it or decide explicitly that you don't want to replicate it, and it can be very expensive. Even replacing the UI level of a stack, even with a new version of the UI framework, often can slow you down for three months to 6 months as you migrate the UI to the new version. It's very painful, and it's something you don't want to do. On the other hand, developers love to play around with new stacks and new technologies, and it's something you often have to guard against very strenuously as a product manager and as somebody representing the business side and also the customers who don't necessarily like to have their application dead in the water in terms of new features and things, even though they might really like the new UI if they got it, if they ever get it. It often feels like if they ever get it. So let me talk about one more important topic, and that's metadata. So metadata is really data about the data. It's a very common phrase. You again probably heard it, or you certainly will hear it as a product manager. And there's things like, I'll just give a few examples because I think that's the easiest way to describe it. So for example, if you're talking about a person, the data about the person is things like the name and the address and maybe the age and things like that. That's the data about the person. The metadata about the person might be where I got that data. So maybe I bought a mailing list that has people's names and email addresses. And so the data about the person is the name and email, but the metadata is the list that I bought. So for each of these users in my list or people in my list, I might have a metadata about where I got that information. Or if the user signed up to my mailing list using a call to action on my website, a metadata might be the call to action that they responded to, because then I can use that metadata to group all the people that responded to a particular call to action to follow up with them about, how they like that. If I gave them a freebie, how did they like the freebie, things like that. So that's some examples of metadata. And also, if the user took an action, maybe they bought something, that might be metadata as well. Now, if your data is about the things you sold, then the data is going to be things like the name of the product. Maybe you're selling some products. The name of the product, the SKU of the product, the price of the product, and the metadata might be the people that bought it. So in this case, the user becomes metadata rather than data. One of the really interesting things about metadata is it's very situational. In different situations, the same data can be considered metadata or data. So for example, in the example of things that people bought, you actually may consider for a particular product the group of people that bought it to be data about that product. Or you may consider it to be metadata about the product, because you may say, well, I'm going to aggregate the information about the people that bought it and somehow represent that as a feature or as a metadata about the product in terms of what demographics like this particular product. So that's the types of things that the way that metadata and data can be kind of slippery and situational. So, for example, a person's age in some situations would be data about that person. In other situations, you might actually think of it as metadata. For example, if they signed up to if they're on your mailing list, you may get the age somehow, and sometimes you may not get the age. Other times, you may consider that metadata, and you may use it for different things. A person's demographics can sometimes be metadata and sometimes be data. Again, it's a little bit slippery. So let me summarize today's video. Today's video was to talk about how technical you have to be as a product manager. And the answer is somewhat technical, just like you have to be good at communication and good at empathy and things like that. You have to know some stuff about technology and about how it goes together. But you don't have to be a coder. You don't have to ever, as a product manager, you're never going to write code, most likely. If you do, it's a little bit unusual, or you're probably part of a startup where everybody does everything. But there are these concepts that you should know if you're a product manager, these technical concepts. And so I gave you 3 of them today. I gave a list of many more. And in future versions of this talk about not technical, no problem, we'll cover others of these concepts. And over time, we'll get to a lot of useful technical concepts to know about. So that's a summary of what we talked about today. Now, I hope you enjoyed this video. And if you did enjoy the video, I certainly would love to have you, subscribe, like, share it with your friends. Leave me comments. I love to get comments because it helps me determine what I should talk about next in the next video and what questions people have. And I guess that's about it for today's video. So hopefully this was useful to you. Let me know in the comments if these concepts were useful to learn about. Maybe you already knew about them and you think this was not a good idea. I'd love to hear that feedback as well. And if there's other technical concepts that you hear bandied about by your technical colleagues and you want to get some insight into what they really mean or what the implications are for you, then let me know in the comments and I'll certainly be more than happy to answer those questions in a video, or we can just have a conversation as well. I'm always open to that. So anyway, thanks again for watching. Don't forget to like, subscribe, and share. I really appreciate it. It's really great. And until next time, key point, I won't be here next week because I'm going to be on vacation, but I will be back the following week. Anyway, that's it. Hope you enjoyed this.